Today's episode is perfect posture with Pythagoras. So we're going to maintain a nice double chin the whole time. We're up against the bathroom door. We're maintaining that spinal alignment with Pythagorean forms. We're maintaining our geocentrism. Okay, so we left off on page 20. And we were talking about the dyad, the monad, and the triad. So to recap, with the dyad arises the duality of subject and object, the knower and the known. With the advent of the triad, however, the gulf of dualism is bridged. For it is through the third realm that a relation, or harmonia joining together, is obtained between the two extremes. While 2 represents the first possibility of logos, the relation of one thing to another, the triad achieves that relation in actuality. If this process of emergence is represented graphically, we can see that the triad not only binds together the two, but also, in the process, centrally reflects the nature of the one in a microcosmic and balanced fashion. And I showed that graphic last time. What we have seen in this example of Pythagorean paradigm based on the universal principles of pure number and form is the emergence of duality out of unity and the subsequent unification of duality, which in turn results in a dynamic differentiated image of the one in 3 parts, a continuum of beginning, middle, and end, or of 2 extremes bound together with a mean term. This process, in fact, is the archaic and archetypal paradigm of cosmogenesis, the pattern of creation which results in the world. As F.M. Cornford has observed, the abstract formula which is common to the early cosmogonies is as follows. 1. There is an undifferentiated unity. 2. From this unity, 2 opposite powers are separated out to form the world order. 3. The 2 opposites unite again to generate life. Cornford goes on to demonstrate how this universal pattern underlies not only the cosmogonies of Greek myth, but also those of the early Ionian scientific tradition, as well as we would note the Hegelian thesis, antithesis, synthesis. We're going to jump to the footnotes, and there's nothing interesting there. It also underlies, as one may suspect, the Pythagorean view of the cosmos, literally world order or ordered world, a term that Pythagoras is credited with first applying to the universe. The word cosmos, in addition to its primary meaning of order, also means ornament. The world, according to Pythagoras, is ornamented with order. This is another way of saying that the universe is beautifully ordered. So this is a pre-Christian concept. You can go back to the atheist versus Christian debates. The atheist would say, oh, the world is ugly, good people are born, babies are born with deformities, the world is an ugly place. Pythagoras was saying that no, the world, the cosmos is beautifully ordered. Now the problem of evil, the problem of ugliness, hopefully eventually is going to be addressed here, but this is the initial, this is the thesis of Pythagoras, which must then be defended, but it's clear this is a pre-Christian thesis. This did not originate with Christianity, as I had originally thought, and as other people had originally put forward. The idea of order is intimately connected with limit, peras, the opposite of which is the unlimited aperion. And these are the 2 most basic and hence most universal principles of Pythagorean cosmology. According to the Pythagoreans, the world or cosmos is compounded of these elements, summarized in the famous table of opposites, which has been preserved by Aristotle in his Metaphysics. And these opposites are limited, unlimited, odd, even, one, plurality, right, left. I should have said right, left. Male, female, at rest, moving, straight, crooked, light, darkness, good, bad, square, oblong. Limit is a definite boundary. The unlimited is indefinite and therefore in need of a limit. Aperion may also be translated as infinite, but it is infinite in a negative sense. That is, it is infinitely or indefinitely divisible and hence weak, rather than the modern positive usage of the term, which is often synonymous with powerful. To avoid any confusion between the ancient and modern meanings, Hyperion has been translated either as indefinite or unlimited in the writings which appear in this book, unless the context suggests otherwise. So another like a Gnostic formulation to illustrate this would be if we talk about unlimited desire. So a fat person has unlimited desire for food. A lustful person has unlimited desire for eros. These are unlimited desires which are negative. Obviously, that we wouldn't associate these with like divinity or godhood or something like that. These would be unlimited weaknesses. Aristotle stated that, or before I even go on, there's that famous quote attributed to Einstein where he says, there are two things in this world which I think might be unlimited, the universe and human stupidity, and I'm not sure about the universe. So that's a sense in which colloquially we would talk about the unlimitedness of our stupidity, and yet clearly intelligence is something which is limited. So to go on, Aristotle stated that the Pythagoreans made everything out to be created of numbers. What he means to say is that everything is created out of the elements of number, which include the limited and the indefinite, the odd and the even. The Pythagoreans were in the habit of representing arithmetical numbers as geometric forms, through which they arrived at some interesting insights. In fact, Aristotle makes reference to this very practice. The Pythagoreans identify the unlimited with the even. For this, they say, when it is enclosed and limited by the odd, provides things with the element of unlimitedness. An indication of this is what happens in numbers. If gnomons are placed around the unit and apart from the unit, in the latter case, the resulting figure is always other. In the former, it is always one. Let's see if the footnote explains something. No, that's just it's from Aristotle's Physics. Aristotle is referring to the following figures. And I will turn the camera around so we can see what those figures look like here. We see some of these figures. Let's zoom in here. So you can see this drawing, you can see this illustration. So that's a little illustrative example there of a square number and an oblong number. So the square number starts off 1, and then it expands to 4 in total, but 3 on the border, and then expands to 9 in total, and 5 on the border, and these are, I forget what the concept is in math. I guess we're talking about squaring a number, so we go from 1 being the first square, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25. So these are square numbers, and they're composed of 1 is then bracketed by 4, 4 containing 3, 3 times 3 then gives us 9, 9, 9 is composed then of 5, 3, and 1. 16 is composed of, and I'm just reading here, it's composed of 7, 5, 3, and 1. And I'm just trying to think off the top of my head what sort of connections we might see here, maybe the Fibonacci sequence or something like that. The other example that's given here is the oblong number. So it starts off as 2, then it expands to 6, then it expands to 12, then it expands to 20, and then it expands to 5 times 6, which is 30. So it expands enclosed, there's 2, and then there's 4, and then there's 6, and then there is 5 plus 3 is 8, and then I'm going to assume the next is 10. So there are these patterns. This is, I guess it's called a carpenter's square. The Greek word gnomon signifies a carpenter's square. So when Aristotle refers to the gnomon, he's referring to these squares that are enclosed by other squares. Gnomons have been placed around the 1, and in figure 4, they've been placed around the dyad. So when you expand from the 1, you get 1 to 4, 4 to 9, 9 to 16, 16 to 25, and so those are all squares. If you expand from the dyad, from 2, you get 2 to 6, 6 to 12, 12 to, what is that, 20, 24, 12 to 20, and then from 20 then on to 30. From the arrangement, several patterns arrive. In the case of figure 3, each gnomon or band of points is odd. In figure 4, each gnomon is even. From the above diagrams, we can easily see why the Pythagoreans in the table of opposites identify the odd and even with the square and oblong respectively. Moreover, the principles of limit and the unlimited are also most manifest in these representations. For figure 3 is limited by the stable form of the square, while figure 4 is infinitely variable. With each successive gnomon, the shape and its corresponding lateral and horizontal ratio changes each time. For it is the nature of the unlimited to be eternally variable and multifarious. So I guess the metaphor that's being used here is that when we start with 1 and go to 4, and from 4 go to 9, and from 9 go to 16, and from 16 we go to 25, the ratio is maintained. It's a 1-to-1 ratio. It's square. It's always the same. And so in that sense, it's limited according to like a logical law, that the ratios, they always conspire A equals A, right? But when we talk about the oblong number, we're talking about something which is unlimited, which has a constantly changing ratio. So we're going from, there's a 2-to-1 ratio, then there's a 3-to-2 ratio, then there's a 4-to-3 ratio, then there is a 5-to-4 ratio, and then there is a 6-to-5 ratio. And that ratio is approaching 1. It's always approaching 1, but it never reaches 1, and none of these ratios are equal to one another. Whereas the ratio of 1-to-1, 2-to-2, 3-to-3, 4-to-4, 5-to-5, that is the same ratio, just represented in parallel forms. 1-to-1 is the same as saying 5-to-5. These are equal. But 2-to-1, 3-to-2, 4-to-3, 5-to-4, 6-to-5, these are not the same ratio over and over again. These are different ratios represented differently. And we're going to pause here and continue shortly.